Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we will see the last 20 questions, that is question number 81 to 100 of UGC NET Electronic Science question paper of December 2020 and June 2021 cycle. First question. Consider the system represented by y of n is equal to 2 into x of n plus 3. The system is linear. Second statement, the system is non-linear. Third statement, the system does not have homogeneity property. And the fourth statement is the system follows the additive property. Now, for a system to be linear, for 0 input, our output should be 0, and also it should not have any extra terms added to the input. So if you see the given system, y of n is equal to 2 into x of n plus 3. Here the plus 3 term indicates that the system is non-linear. That is, for 0 input, our output will not be 0. It will be 3. So the system is non-linear. Next, homogeneity property is alpha into x of n is equal to alpha into y of n for all alpha. The given system, if you see, if you multiply by any scalar alpha into the input x of n, our output will not be equal to alpha into y of n. So it does not have homogeneity property. Here statements 2 and 3 are correct. So option C is the correct answer. Next question. It is match the following type. First, low pass filter. The frequency response of low pass filter is the third figure, because it passes all the frequencies below the cutoff frequency. And next, high pass filter. Here the frequency response for high pass filter is the fourth figure, which allows all the frequencies above the cutoff frequency. And band pass filter. Here the band pass filter passes the frequencies between upper and lower cutoff frequencies. So here figure 2 is the valid one for band pass filter, and for band reject filter, it allows frequencies beyond upper and lower cutoff frequencies. So first figure is for band reject figure. Hence option C is the correct answer. Next question. Consider the following circuits and arrange them in ascending order of their complexity. First order low pass filter, second Sallen key filter, third fourth order Butterworth low pass filter, fourth non-inverting amplifier. If you see, the complexity is very low for non-inverting amplifier, and then for first order low pass filter, and after that Sallen key filter, and after that fourth order Butterworth low pass filter. So option C is the correct answer. Next question. Which of the following statements are correct? First statement, M-array modulation scheme is preferable where the bandwidth requirement is important. Second statement, M-array PSK system, that is phase shift keying system, considers m different phases in the range pi by 2. Here if you see, the first statement is correct because M-array modulation scheme is preferred where the bandwidth requirement is very important. Here the second statement is wrong because the m phase angles are theta I is equal to 0, 2 pi by m, which goes on up to 2 into m minus 1 divided by m into pi. And the third statement, in M-array modulation scheme, only coherent deduction is possible. This statement is correct. And the fourth statement, M array QAM, that is quadrature amplitude modulation scheme, uses M square carrier signals having the same frequency. This statement is wrong because it uses only 2 carrier signals. So statement 1 and 3 only are correct. So option B is the correct option. Next question, the Q of the coil, that is the quality factor of the coil using series connection measurement method, is given by which of the following equations? Now, the quality factor of the coil can be found using series connection by using the formula Qs is equal to C1 minus C2 into Q1 into Q2 divided by C1 into Q1 minus C2 into Q2. Here C1 and C2 are the two different capacitors which operates at different frequencies, and Q1 and Q2 are their corresponding quality factors. So option B is the correct answer. Next question, a single phase 220 volt 1 kilowatt electric room radiator is connected across 220 volt supply through a triarc. For a delay angle of 90 degree, the value of power dissipated by the radiator is option A 2500 watts, option B 398.9 watts, option C 49.985 watts, option D 500 watts. If you see the solution, first we have to find the effective resistance of the radiator, which is given by the formula R is equal to V square by P. Here V is the voltage, rated voltage 220 volt, and 1 kV is the power, rated power of electric room radiator. 1 kilowatt is nothing but 1000 watts. So substituting, we have the effective resistance as 48.4 ohms. Now the RMS value of output voltage of the controlled rectifier, that is fully controlled rectifier using triarc, is given by Vrms is equal to Vm by root 2 into 2 into pi, the whole into pi minus alpha plus sine 2 alpha by 2 whole to the power half. We know that the maximum voltage Vm is nothing but 220 volt into root 2, and substituting alpha is equal to pi by 2, we have the output RMS voltage as 155.56 volt. Now the power dissipated by the radiator can be found P is equal to V square divided by R. Substituting V is equal to 155.56 volts and resistance R is equal to 48.4, we have the power dissipated by the radiator as 500 watts. So option D is the correct answer. Next question. The three basic structure types used to write the algorithm for a program are sequence, selection and repetition. Which of the following is not an advantage of using only these structures when writing the algorithm for a program? They have given which of the following is not an advantage. If you see option A, algorithm has very low space complexity. This is a disadvantage. Algorithm is easy to debug. It is an advantage. Algorithm is easy to implement. Algorithm is easy to understand. So these are all the advantages, but they are asking not an advantage. So the only disadvantage is algorithm has very low space complexity. So option A is the correct answer. If AFT is the total pass band gain, FL is low cutoff frequency, FH is high cutoff frequency, then voltage gain magnitude of a band pass filter is given by. The formula for voltage gain is V0 by Vin is equal to AFT into F by FL divided by square root of 1 plus F by FL square into 1 plus F by FH square. So option C is the correct answer. Next question. If the in-phase and quadrature components in an M-array PSK system are permitted to be independent, then this scheme becomes a option A DPSK, option B FSK, option C M-array QAM, option D QAM. So here the correct option is M-array QAM, that is M-array quadrature amplitude modulation is the scheme when the in-phase and quadrature components in M-array PSK, that is phase shift keying system, are permitted to be independent. Next question. In MOSFET, the channel resistance of an elemental section dy is given by the formula dy divided by z into mu n into magnitude of qn of y. Here z is the width and mu n is the mobility and qn is the charge in the inversion layer per unit area. In MOSFET, the threshold voltage under idealized condition is given by the formula Vt is equal to 2 into psi b plus square root of 2 into epsilon s into q into Na into 2 into psi b divided by Ci. Here psi b is the barrier potential and epsilon s is the permittivity and q is the charge of electron, Na is the doping density and C is the capacitance. So option C is the correct answer. Next question. In MOSFET, the drain current density including both drift and diffusion component is given by the formula Q into mu n dot n into Ey plus Q into dn into del n. Here the first term represents the drain current density due to drift component and the second term represents the drain current density due to diffusion component. Here Q is the charge of the electron, mu n is the mobility and dn is the diffusion constant. E is the electric field. So option D is the correct answer. In MOSFET, the one-dimensional Poisson equation for the surface phase charge region at the drain is given by the formula dou square psi by dou x square is equal to minus q by epsilon s into nd plus minus na minus plus p minus n. Here nd plus is the donor concentration, donor ion concentration and Na minus is the acceptor ion concentration and P is the number of holes and N is the number of electrons. So option A is the correct answer. In N-channel MOSFET, the charge induced in the inversion layer per unit area at the distance y from the source is given by the formula Qn of y is equal to minus Vg minus psi s of y into Ci minus Qb of y. Here Vg is the gate voltage, psi s of y is the surface potential at a distance y and C is the capacitance and Qb is the barrier. Option B is the correct answer. Next question. A filter is needed to remove induced 60 Hz hum from a transducer signal. The rejection bandwidth is 2 Hz. The correct combination of damping resistance and capacitance values for this filter are option A 30 ohm 32.5 millifarad, option B 68 ohm 30.5 millifarad, option C 82 ohm 3.25 millifarad, option D 89 ohm 2.65 millifarad. Now here band reject or notch filter is used to remove the hum from a transducer signal. Now the quality factor for this filter will be Q is equal to 60 divided by 2. that is the induced frequency divided by bandwidth frequency, which will be equal to 30. So our quality factor is 30. Now the damping resistance is given by the formula 3 into Q minus 1. So substituting Q is equal to 30, we have the damping resistance is equal to 89 ohm. Now the angular frequency omega naught is equal to 2 pi into 60. 60 is the induced frequency, is equal to 377 radian per second. Now scaling C produces the value of C is equal to 1 by omega naught, which is equal to 1 by 377. So solving, we have C is equal to 2.65 millifarad. That is, the capacitance value is 2.65 millifarad. So option D is the correct answer. Next question. Which of the following statements is not correct for a Chebyshev filter? Option A. Chebyshev filter tends to exhibit ringing effect with transient signals. This statement is correct. Next statement. Chebyshev filters are capable of achieving more attenuation in stop band. This statement is also correct. Note they have asked not correct statement. Third statement. Chebyshev filters have a sharp slope than Butterworth filters. This statement is also correct. Time delay and phase characteristics of Chebyshev filter are comparatively better than that of Butterworth filter. This statement is wrong. So option D is the correct answer. Next question. The characteristic equation for the output voltage of an all-pass filter is given by the formula V0 is equal to Vn into minus 1 plus 2 divided by J into 2 pi f into Rc plus 1. So option C is the correct answer. Next question. Which of the following statements are correct for active filters? First statement. Multiple feedback are preferred for quality factor less than or equal to 10. This statement is correct. And for quality factor greater than 10, state variable filter is used. This statement is also correct. The upper and lower cutoff frequencies have arithmetic symmetry about center frequency Fc for smaller Q values. This is wrong statement. As quality factor is increased, the filter becomes less selective and both upper and lower cutoff frequencies approximate geometric symmetry. So this statement is also wrong. So option A is the correct answer. Next question. Which of the following statements is not correct about Butterworth filter? First statement. Butterworth filter is characterized by its moderate amplitude and phase response. The statement is correct. As we know, Butterworth filter is the most popular alignment type. So this is also correct. It exhibits the slowest roll-off of any monoatomic, that is single slope filter. This statement is wrong. This is the only filter whose 3 decibels down frequency equals its critical frequency. So this statement is also correct. So option C is the correct answer. They have asked a not correct statement. So you have to carefully note down the question. Next question. The ripple counter shown in the following figure uses flip-flops that trigger on the negative edge transition of the clock pulse input. Is the counter self-starting? Option A, no. Option B, yes, when all the inputs are 0. Yes, when all the inputs are 1. Option D, yes. Here, option D, yes, is the correct answer. Let us see the solution. First, let us consider the flip-flops from right side as F0, F1 and F2. The output of these flip-flops be Q0 and Q0 bar, Q1 and Q1 bar and Q2 and Q2 bar. the output of our AND gate is Q1 into Q0. If you see the second flip-flop, the input to these flip-flops are J is equal to 1 and K is equal to 1. That is, it operates in toggle mode. Toggle mode is what? If J is equal to 1 and K is equal to 1, our n plus 1 state will be complement of previous state. Whenever negative edge clock pulse is given, this flip-flop toggle its output. Now, let us solve this problem. First, let Q2, Q1 and Q0 be reset, that is clear. So, their output values will be 0, 0, 0. During first negative edge transition, that is negative edge is nothing but from high to low. Input to the F0 flip-flop is J and K will be equal to Q2 bar. Here they are assumed Q2 is equal to 0. So Q2 bar C will be equal to 1. So the output of Q0 will be 1. Since J is equal to K is equal to 1. Now the Q0 output has changed its states from 0 to 1. That is 0 to 1 means low to high. So it is positive edge triggered. So this is given as clock input to the second flip-flop. So since it is positive edge, second flip-flop will not change its state. So its state will be as such, that is 0. Now the input to the third flip-flop will be J is equal to Q1 dot Q0, which is equal to 0.1, which will be again 0, and our K is nothing but Q1 bar, which is equal to 1. So for J is equal to 0, K is equal to 1, our output Q2 will be equal to 0. That is reset condition. Similarly, for second negative edge transition clock pulse, we have 0, 1, 0, and for third negative edge 1, 1, 1, and for fourth negative edge we will have 0, 0, 0. That is, the flip-flop is cleared. It again restarts to its original position. Now if you see this counter, here the valid states are 0, 1, 2 and 7. So after that the counter again goes to 0, and the invalid states are 3, 4, 5 and 6. A self-starting counter is a counter which goes back to valid state, whether it starts in from valid state or from invalid state. It should go back to valid state. So let us check. Suppose if the counter is in invalid state 3, that is Q2 is equal to 0, Q1 is equal to 1 and Q0 is equal to 1. During first negative transition, our Q0 will be equal to 0 because its input is J is equal to K is equal to 1, which is nothing but Q2 bar. So the first flip-flop output Q0 will change from 1 to 0, and similarly the second flip-flop Q1 also changes from 1 to 0 because here negative edge transition is given as clock pulse to this flip-flop. Now for the third flip-flop, J is equal to Q1 into Q0, which is equal to 0 into 0. So 0, and K is equal to Q1 bar. So Q1 is equal to 0, Q1 bar will be 1. So for J is equal to 0 and K is equal to 1, our output will be 0. So the counter enters into a valid state. Similarly, if you assume invalid state, that is 4, 1, 0, 0, for that also it enters into valid state 0, 0, 1. So this counter is self-starting. Thanks for watching the video. For more videos, don't forget to subscribe our channel.